All right, I'm going to jump right into this. We're going to write some proofs using supplementary angles. And I think before I get started, I'm going to illustrate exactly what it is we're trying to show using supplementary angles. So to get things started, I'm going to draw a couple pairs of supplementary angles. Angles 1 and 2 are supplementary because they form a linear pair. They're on the same straight line. 3 and 4 are supplementary because they too form a linear pair or are on that same straight line. I'm going to say that if angles 1 and 3 are congruent, we know that their supplements 2 and 4 have to be congruent as well. This is a fairly simple idea to understand. It's a little more complicated and complex to write about in a proof. The congruent supplements theorem says exactly what we just said. It says that when two angles are congruent, their supplements are congruent. Or congruent angles have congruent supplements. So all three of those say exactly the same thing. All right, where might this be helpful? Where might this be useful? Let's jump into number 1. It says given segments AP and CP are congruent, angles APD and CPD are congruent, and points B, P, and D are all on the same straight line. And our goal, our mission, like usual, is to prove those triangles congruent. So I've got the given pair of segments. I've got a pair of segments BP congruent to itself because they're shared sides right up the middle there. But the problem with my given pair of angles, APD and CPD, is that they are outside the triangle rather than inside the triangle. But while the given pair of angles is outside the triangle, note that their supplements are inside the triangle. And if the angles outside the triangle are congruent, then their supplements inside must be. So I'm going to say angles 1 and 2 have to be congruent to each other because they are the supplements of the given pair of congruent angles. So as far as my outline, or what I'm going to talk about or speak to in this proof, is concerned, that looks to me as if this is going to be a side angle side proof, with my first pair of sides being that reflexive property up the middle. My second pair of congruent sides being the given pair. And my congruent angles being those supplements of the given angles. And again, note that I cannot use the given angles because those angles are outside of the triangles. All right, so I've got my outline. Let's go talk about these things I want to talk about. Thing number 1 in my list, segment BP congruent to itself by the reflexive property. All right, next item in my little checklist are those supplementary angles 1 and 2. This is a little tricky to write about. I knew that they were congruent to each other because they were supplements of the given angles. So I have to talk about angle 1 being a supplement of angle APD and angle 2 being a supplement of angle CPD. I know they're supplements of each other because they form linear pairs. So my reason here is going to be to say linear pairs are supplementary. You could say angles on a straight line are supplementary. I knew that angles APD and CPD were congruent. I knew that because it was given to me that they were congruent. So because those angles are congruent, I know that their supplements, 1 and 2, must also be congruent. And that, as far as a reason, I can say congruent supplements theorem. I can say when two angles are together congruent, their supplements are congruent. I can say congruent angles have congruent supplements. But making those supplementary angles congruent is always a three-step process. You have to talk about the supplementary angles. You have to talk about the congruent angles. And then lastly, you can talk about the congruent supplements. All right, so item number 2 checked off my list. Boom. Item 3, segments AP and CP. Well, I know those are congruent to each other because it's given to me that they're congruent. This is a pair of congruent angles. So now I think I've got what I need. I've talked about, written about my 2 pairs of congruent sides as well as my pair of congruent angles. I'm all legit now to say that triangle APB is congruent to triangle CPB. And our method that proves congruency here, oldie but a goodie, side angle side. All right, so there it is in action, guys. Congruent supplements theorem. Remember, in order to use it, you have to have congruent angles and you have to have supplementary angles. All right, let's keep this party moving here. Onwards. Number 2, given angle CDE is congruent to CED. So there's the given angles. Segments AD and BE are congruent, and segments CD and CE are congruent. And our goal, our mission is to make triangle ACD. Since there's a lot of triangles floating around in this picture, I'm going to highlight the 2 I want to make congruent. So it's those yellow triangles I'm trying to prove congruent. And we can see that very similar to the first example, the angles that are given to us as being congruent are the angles outside those yellow triangles. But I know that if those angles outside the triangles are congruent, I know that their supplements inside the triangles have to be congruent as well. And I'm looking, I think I marked something wrong here because I'm looking for a congruency method and I'm not seeing one. So let's see, CD I should have marked congruent to CE. So let me go back and make that right. Thank goodness for erasers. Perfect. Now that's looking a lot better. So now I'm seeing side angle side, just like with the first proof. So my pairs of sides come from the given information. And my angles I'm going to call 1 and 2. You can name them using 3 letters. You are more than welcome to do that. I think it's easier to name them using some numbers. So again, it's just all a matter of personal preference. All right, this is for all of my 2-column people out there. Remember that when you write a 2-column proof, you must have a column that represents the statements, you must have a column that represents the reasons, and you must label both. right, I'm going to remember, just to be efficient, that when statements are true for the same reason, I can include them in the same statement in my proof. So I'm going to start out by saying segments AD and BE are congruent, as are segments CD and CE. And again, the reason I can put them there is because they are both true for the same reason. And that is my favorite reason in the whole world. They are given to me to be true statements. All right, I want to use my congruent supplements theorem, but in order to do that, I have to have a pair of congruent angles, which would be the given angles CDE and CED. And I have to have a pair of supplementary angles. So this is the piece I'm going to have to work for just a little bit here. So angle CDE is supplementary with angle 1. Angle CED is supplementary with angle 2. And that's because linear pairs are supplementary, or angles on a straight line are supplementary, however you want to word that. So now in step 2, I've talked about my congruent angles. In statement 3, I've talked about my supplementary angles. Now I can use my congruent supplements theorem to conclude that angles 1 and 2 are congruent. And again, I'm going to write congruent supplements theorem, but you could write when angles are congruent, their supplements are congruent. You can say congruent angles have congruent supplements. I'm going to cite statement 2 because statement 2 was where I had my congruent angles, and statement 3 because that was where I had my supplementary angles. And I think now I've written about everything I need to have written about in order to draw the conclusion that my triangles are congruent. So last step here is to go ahead and conclude that triangle ACD is congruent to triangle BCE, and that's by side angle side using statements 1 and 4. So let me go ahead and cite those in my proof. Ooh, that was a good one. All right, so congruent supplements theorem, this is my take on congruent supplements theorem. It's kind of an easy theorem to understand, but a tricky one to write about. That said, I have every faith, every confidence you're able to do it. If you have questions, write them down so you can remember to ask when we come back together face to face, or you're always welcome to email me about them right now so that you don't forget. As always, thank you for the gift of your time and watching the video, and I can't wait to see you again when we're able to come back together face to face in the classroom.